press the bell icon on the YouTube app and never miss another update.
Hello students, today we discuss one more concept in application of derivatives. The concept is maxima and minima. So this is the last concept in application of derivative, and very important concept, very easy concept. Okay, first we see when the function is maximum and when the function is minimum. Okay, for that what I do, I draw two curves. So this is origin, everything you know, the plane. Here also I draw when the curve is in between the interval a to b. Okay, this is the point x is equal to, the domain is c, x is equal to c. So one more I draw here, same the interval s, then this is the interval, close interval a to b, and this is the point x is equal to b. This is what x axis and y axis origin. We will see when the curve is maximum and when the curve is minimum without using derivative. Okay, after we will see how to find the maxima and minima with using derivative. See, observe here. So this is the curve. In this curve, the tangent goes on what? Increasing. Correct na? The tangent goes on increasing, and at x is equal to c, the tangent is what? Parallel to x axis. Correct? At x is equal to c, tangent parallel to x axis. Firstly, the tangent goes on what? Increasing. That's why I write arrow mark like this. The tangent goes on increasing at the point x is equal to c, the tangent parallel to x axis. Then what will happen? It goes on, the tangent goes on decreasing. The tangent goes on decreasing. So this point we call it as point of maxima. If the curve goes on increasing and it is parallel to x-axis, then it goes on decreasing, then that point we call it as what? Point of maxima. And this range value, I call it as f of c, is called f of c is called maximum value. F of c is called what? Maximum value. One more condition, and this f of c, observe here, this f of c is always greater than f of x for each x belongs to close interval a to b. Correct now? See the range of the value. This f of c value, this is very important. This f of c value greater than f of x. F of c value greater than what? F of x for each x belongs to close interval a comma b. That means the curve is continuously on close interval a comma b and differentiable on open interval a comma b. Then only we find maxima and minima. When the curve is maximum, if f of c, the range f of c is greater than f of x for each x belongs to what? A comma b. Then that point we call it as point of that domain. So this is nothing but a domain. That domain we call it as what? Point of maxima or else local maxima. One more word, local maxima. This is what the concept of maxima. So the concept of maxima, the tangent goes on increasing, correct na? And it parallel to x-axis. This is very important. It parallel to x-axis, then it goes on. What? Decreasing. Increasing and reaches and parallel to x-axis, then it goes on decreasing. See, the word says maxima, highest value. F of c is the highest value for all f of x for x belongs to a comma b. This is what the concept of what? Maxima, without using derivative. We will see this one. Observe this one. Here the tangent goes on what? From each point. For each point the tangent goes on increasing or decreasing? Decreasing. And it reaches it at x is equal to c. The tangent is what? Parallel to x-axis. At x is equal to d, tangent parallel to x-axis. Correct? Firstly, the tangent goes on decreasing. The tangent goes on decreasing at x is equal to d. The tangent parallel to x-axis. Then it goes on increasing. The tangent goes on increasing. This is what the point x is equal to d is called point of what? Minima. X is equal to d is called what? Point of minima. And one more very important, f of d, the range. F of d is always less than. Here it is always greater than. Correct now? Maxima, highest value. Minima, least value. The word says that minima means least value. F of d is always less than f of x for each x belongs to what? Close interval a comma b. Means it is continuously on close interval a comma b, differentiable on open interval a comma b. This f of d is called, right here, is called minimum value. This f of d is called what? Minimum value. This is what the concept of maxima and minima. When the function is maximum, f of c is greater than, simply I say. When the function is maximum, f of c, the range, is greater than f of x for each x belongs to a comma b. When the function is minimum, f of d is always less than f of x for each x belongs to a comma b. This is what the concept of what? Maxima and minima. This domain we call it as point of maxima, and this domain we call it as point of minima. Correct? Point of, and f of c we call it as maximum value. Here f of d we call it as what? Minimum value. This one more. This d is called local minima. Both are same. Okay. Minima is also minima or local minima. Minima or local minima. Both are same. So point of minima, local minima. X belongs to for each a comma b. When the function is maximum, f of c is greater than f of x for all x belongs to a comma b. When the function is minimum, f of d is less than f of x for each x belongs to what? A comma b. And the point d is called point of local minima. This is about the concept of what? Maxima and minima. Concept of maxima and minima without using, understand, without using derivative test. Without using what? Derivative test. So three concepts are there. So he asks, find the point of maximum, local maxima, or find the maximum value, or find the minimum value. Three concepts are there. First concept is without using derivative. What we discuss just now. This is the concept. without using derivative. Second concept, using first order derivative test. So we will see the first order first order first order derivative test when the function is maxima and when the function is minima. Observe here, so at I write the interval a to b. This is the point x is equal to c. At this point, f dash of c is equal to what? 0. Correct? F dash of c at this point means the tangent is parallel to x-axis, means f dash of c is what? 0. And here what? It is increasing, means f of x is increasing, positive. Correct? F dash of x means if you want f dash of x greater than 0, what we discuss in the increasing decreasing function, same. Here it is f dash of x from a to c, f dash of x is increasing from c to b, f dash of x what? Decreasing. If when it is maximum in the closed interval at x is equal to c, f dash of c is equal to 0, this point we called as point of inflection, or else, so what we did, the tangent is parallel to x-axis. When it is maximum from a to c, it is derivative is positive, from c to b the derivative is negative, then f of c we call it as what? Maximum value. X is equal to c we call it as point of maxima. From positive to negative, f dash of x greater than 0. Here it is an increasing function and here it is an decreasing. From increasing and parallel and decreasing, means increasing means what? The derivative is greater than 0. Decreasing means what? The derivative is less than 0. What we discussed in the last session, increasing decreasing function. So from a to c the function is increasing. From c to b the function is decreasing. If the function increasing and parallel to x-axis, then it is decreasing. Using the first order derivative test, x is equal to c, we call it as point of maxima, and f of c we call it as maximum value. This is what? The first order derivative test. Why I discuss increasing decreasing function lastly? Because I linked to here. First order derivative test, when it is maximum value a to c, it is positive. That means it goes on increasing. Here what? F dash of x greater than 0 from a to c. C to b, f dash of x less than 0. Here it is positive. Here it is what? Negative. Here it is positive and here it is negative. And this point f dash of c is equal to what? 0. F dash of c is equal to what? 0. Point of inflection. What we discussed, increasing from positive to negative. If the function from positive to negative means it is increasing, then parallel to x-axis, then it is decreasing, then this point we call it as what? Point of maxima. And f of c, what the range? F of c we call it as maximum value. This is for first order derivative test. So when the function is minima, that is very important. So observe here. So I draw one more line segment a to b at x is equal to d. You only understand at x is equal to d. Here f dash of x less than 0, correct na? Negative. Here f dash of x greater than 0, what? Positive. Less than 0, greater than 0. At x is equal to d, f dash of, I write here, f dash of d is equal to 0. Here from positive to negative, here from negative to positive, f dash of x less than 0, f dash of x greater than 0. From negative to positive. From negative, says the tangent is decreasing. So if it is decreasing and it is parallel to, if it is decreasing and parallel to x-axis, then it is goes on increasing. Then it is goes on increasing. If this condition satisfies, this point, D point, we call it as point of minima. This point we call it as what? X is equal to D, we call it as point of minima. F of D, what be the range? That we call it as minimum value. Clear? So from negative to positive, from negative to positive, here it is A to B, observe at x is equal to C. Here it is positive to negative. Here it is negative to positive. Here it is positive to negative. It is increasing, then reaches parallel to x-axis, then it is decreasing. So point of maximum. Decreasing parallel to x-axis, then it is increasing, point of minima. This is what, how to find what? Maxima and minima using first order derivative test. Correct? Understand? Using first order derivative, what we do? Simply what we follow, increasing decreasing function, same concept. Firstly, we have to differentiate and equate to 0. We find point of inflection. Then, so it divided into two intervals, two part, A to C, C to B. We find A to C whether it is positive or negative, C to B whether it is positive or negative. If it is positive, then it is negative. This point we call it as point of maxima, and if it is negative and positive, this point we call it as point of minima. So point of minima, point of maxima, the range value f of C and f of D. F of C we call it as maximum value, f of D we call it as what? Minimum value. This is what the concept using first order derivative test, what we follow in increasing decreasing function. We will see very important concept, how to find maxima and minima by using second order derivative test. This is very important. In the problem, we solve by using only second order derivative test. See, very important concept. How to find what? The maxima and minima. How to find the maxima and minima using second order derivatives test. Maxima and minima using second order derivative test. Firstly, he has given y is equal to f of x. So what I follow in the problem, same steps we will discuss. Okay. So first step, differentiate with respect to x, dy by dx. That is what? F dash of x. Okay, y is equal to f of x. First step, we have to differentiate dy by dx. Dy by dx is equal to what? F dash of x. Then we equate f dash of x to 0 to find critical points. Say x is equal to C and x is equal to D. Next, what we do? What we follow in the increasing decreasing function? Same concept. Firstly, we find differentiated. Okay, first order we have to differentiate. Equate to 0. Why equate to 0? To find the critical points. Critical points means what? Critical point means at that point derivative is 0. Derivative is 0 means tangent is parallel to x-axis. Correct now? Tangent is parallel to x-axis. We got here, I got two critical points. I don't know the function. In this function, the function means I think cubic. If you derivative, it becomes quadratic. So we got two critical points. Nextly, what we do, once again, differentiate with respect to x d square y by dx square. That means what? F double dash of x, f double dash of x exists. So the function second order derivative test is exist. Once again, what we do, we differentiate the function d square y by dx square, f double dash of x exists. So what we do, first I take at d square y by dx square at x is equal to c. That means f double dash of c, not f dash of c, f double dash of c less than 0. That means negative. Very important. Observe here, d square y by dx square at x is equal to c. I take the first critical point. Okay na? Substitute here. So what we do, we substitute the first critical point to the second order derivative test. So I calculate it. So we got the result is less than 0. That means what? Negative. In this condition, observe carefully, f of x is maximum at x is equal to c. This is very important. If the negative comes, you write it is minimum. That is wrong. Second order, once again, carefully observe, second order derivative at x is equal to c is less than 0. That means what? Negative. F of x, the function, is maximum at x is equal to c. Clear? If negative comes, once again, this is very important, f double dash of c less than 0. That means negative comes, f of x is maximum at x is equal to c. Or else local point of local maxima. This point we call it as point of what? Local maxima. So we find maximum value. What we do? We substitute x is equal to c in the function. F of c is called maximum value. F of c is called maximum value. I think you clear. Firstly, we have to differentiate. We got the critical points. Then once again, we have to differentiate. Substitute the first critical point, means any one of the critical point. If it is negative means less than 0, f of x is maximum at x is equal to c. Then that point we call it as point of local maxima. Maximum value we want, substitute x is equal to c in the function. What we got the range, that range is called maximum value. Second one, so one more domain is there, critical point, d square y by dx square, f double dash of d greater than 0, negative over, it is positive. If the second order derivative is positive at that domain, f of x is minimum. F of x is minimum at x is equal to d. Means this point we call it as point of local minima. Point of what? Local minima. So f of d is called minimum value. F of d is called what? Minimum value. If it is negative, it is maximum. If it is positive, it is minimum. This is very, very important. Second order derivative is negative, then that point we call it as point of maxima. Second order derivative is positive, that point we call it as what? Point of minima. F of d means what we do? If we substitute x is equal to d, x is equal to d in the function, what we got? The range. That range value we call it as minimum value. Clear the concept? This is what? The second order derivative test. One more, I think in your mind one more comes. So less than 0 over, greater than 0 over. Suppose, sir, third condition, right here only, f double dash of cd over e is equal to 0, sir. If 0 comes, correct na? If 0 comes, what we write the answer, sir? Neither maxima nor minima, the test fails. Second order derivative test fails. Under that condition, we go for first order derivative test. We will see in the problems. Okay. So if I say now only, you are not clearly understanding. You simply observe if it is negative, maxima, if it is positive, minima. If it is equal to 0, second order derivative test fails. So neither maxima nor minima, that conclusion we got by using first order derivative test. For that we have to differentiate once again. Third order derivative test we have to find out. We will see the later. Okay. So when the function is, once again I say that, when the function is maxima at x is equal to c, f double dash of c is what? Negative. When the function is minima at x is equal to d, f double dash of d is what? Positive. So that domain we call it as point of local minima or point of local maxima. The range what we got with respect to the domain, that we call it as maximum value or minimum value. This is what the concept of second order derivative test. This is what the concept of second order derivative test. We will see the problems. So I explain all three concepts without using derivative. First order derivative are linked to the increasing decreasing function, first order derivative test, and second order derivative test. So what we do, all the problems in maxima and minima, increasing decreasing you know, means first order derivative test you already know. Correct na? So what I do, all the problems I solve by using what? Second order derivative test. Okay na? So we will see the problems. So in that maxima and minima exercise, so first I solve third main problems. In third main problems, what he has, find the local maxima and local minima, if any, of the following functions. Following function. Find also the local maximum and the local minimum value. Find also the local maximum value and the local minimum value. Enter that first problem, first one. F of x is equal to what? X square. F of x is equal to what? X square. What we discuss? I solve all the problems by using what? Second order derivative test. If you want, you solve first order derivative test. That is nothing but the concept of increasing decreasing function. Clear now? Okay. So firstly, what I do, differentiate with respect to x, because x is an independent variable. F dash of x to x. Clear? So f dash of x is equal to 0. 2x is equal to 0. X is equal to 0. Only one critical point we got. Only one critical point we got. Okay. Next. So this is nothing but the critical point. Critical point. What we do? We differentiate. Again. With respect to x. That means f double dash of x, it is what? 2. F double dash of x is what? 2. Correct? Next step. F double dash of 0 or else f double dash of x at x is equal to 0. Wherever x present in f double dash of x, substitute 0. Is a constant function. It is 2. It is 2. So we don't want the value. We want the sign. Whether it is positive or negative, it is positive. Greater than 0. Positive. If it is positive, that implies at x is equal to 0, f of x is maxima or minima? Minimum. This is very important. F of x is minimum. That next line. Hence, x is equal to 0 is called point of local minima. Or else if you write simply minima, no problem. Point of minima or else point of local minimum. So next what we find? Local minimum value. Or else just simply minimum value, local minimum value. What we do? We substitute x is equal to 0 in the function. F of 0 square is equal to 0. Lucky number. 0 square is equal to what? 0. So this is what? Using second order derivative test. See this problem carefully. So I solve all problems in maxima and minima by using what? Second order derivative test. If you want, you solve in first order derivative test also. So first order derivative test, what we use means minimum means it is decreasing in that left side interval, then it is increasing in the right side interval. If you want, you check out. Okay, this is what the concept. First problem. See this problem very carefully. Next problem. Second problem, g of x x cube minus 3x. G of x, x cube minus 3x. Okay, same. Differentiate with respect to x. G dash of x minus 3. Differentiate again with respect to x. G double dash of x 6x. Okay, we find both order, first order as well as second order. To find critical point, let G dash of x is equal to 0. That implies 3 into x square minus 3 is equal to 0. If I take 3 common, x square minus 1 is equal to 0. X square minus 1 is equal to 0. X square is equal to 1. X is equal to what? Plus or minus 1. That implies x is equal to 1 or x is equal to minus 1. We got what? We got what? Two critical points. Plus 1, minus 1. Correct? Plus 1 and minus 1. First one. G double dash of 1. 6 into 1. 6 greater than 0, positive. That implies at x is equal to 1, g of x is minimum. Correct? If it is positive, it is minimum. Next, x is equal to 1 is called point of local minima. X is equal to 1 is called point of local minima. Local minimum value g of 1 cube minus 3, 1 minus 3 minus 2. First domain is over. Clear? Second. First one is over. Second one, g double dash of minus 1. 6 into minus 1. Minus 6 less than 0. Negative. At. That implies at x is equal to minus 1. G of x is maximum. X is equal to minus 1 is called point of local maxima. Point of what? Local maxima. Then local maximum value g of minus 1 cube minus 3 into minus 1. What? Minus 1 cube is minus 1, minus into minus plus 3, it is 2. Understand? See this problem. So we got two results, minimum value as well as maximum value. This is very important concept. See this problem very carefully. Next problem. Third problem, h of x sin x plus cos x. He has restricted the domain greater than 0, less than pi by 2. Means We have to find out the critical points in between 0 to pi by 2. Same procedure. What we do? H dash of x cos x minus sin x. H double dash of x minus sin x minus cos x. Derivative of cos x is minus sin x. Derivative of sin x is cos x. H dash of x is equal to 0. Cos x minus sin x is equal to 0. Cos x minus sin x is equal to 0. Cos x is equal to sin x. Tan x is equal to 1. Correct na? Tan x is equal to 1. Sin x by cos x, tan x is equal to 1. So when it is 1, x is equal to pi by 4. Correct? X is equal to pi by 4 is the critical point in between 0 to pi by 2. Only one critical point. In third quadrant also we got the critical point, but the restriction. We find the critical points, we say it is maxima and minima in the open interval 0 to pi by 2. It is not closed interval. Okay, 0 to pi by 2. Then what we do? We substitute here. Hash double dash of pi by 4. Check out. Minus sin pi by 4 minus cos pi by 4 minus 1 by root 2 minus 1 by root 2 minus 2 by root 2 minus root 2 less than 0 negative. That implies x is equal to x is equal to pi by 4. H of x is maximum. H of x is maximum. Next line. Next line. X is equal to pi by 4 is called point of local maxima. Point of local maxima. Local maximum value. Local maximum value. What we do? Substitute at pi by h of pi by 4. We have to find out the range. Sin pi by 4 cos pi by 4 1 by root 2 plus 1 by root 2. Correct? 2 by root 2. So this simply written as what? Root 2. Correct? This value we call it as point of maximum value, and x is equal to pi by 4 we call it as point of local maxima. Next problem. Fourth problem. F of x is equal to sin x minus cos x. Same problem, but plus in the last problem here it is minus. Then domain he has given greater than 0 less than 2 pi. Greater than 0 less than 2 pi. Same procedure. Firstly find f dash of x. Correct na? Sin x. F double dash of x minus sin x cos x. F dash of x is equal to 0. Cos x plus sin x is equal to 0. Cos x is equal to minus sin x. Correct? Tan x is equal to minus 1. Tan x is equal to minus 1. So when it is x is equal to 3 pi by 4, one value, because 0 to 2 pi, so it is negative in second quadrant, it is also negative in fourth quadrant, 7 pi by 4. 3 pi by 4 and 7 pi by 4. These two are what? The critical points. These two are what? The critical points. You auto check, you also check. And that these 2 points, the tangent is parallel to x-axis. So one by one we have to find out. F double dash of 3 pi by 4 minus sine 3 pi by 4 plus cos 3 pi by 4. You know how to solve big. Once again I say that minus sine. This we can written as pi minus pi by 4 plus cos pi minus pi by 4. Correct? So we substitute here. Minus sine 180 minus theta pi by 4 minus cos pi by 4. 180 minus theta. In second quadrant sine is positive, cos is negative. So minus 1 by root 2 minus 1 by root 2 minus root 2 less than 0 negative. What the conclusion? The conclusion at x is equal to 3 pi by 4 f of x f of x is maximum. X is equal to 3 pi by 4 is called point of local maxima. Point of what? Local maxima. Then local maximum value. Local maximum value f of 3 pi by 4 sine 3 pi by 4 minus cos 3 pi by 4. Write direct because I solved here. That's why I write direct. 1 by root 2 minus of minus plus 1 by root 2, it is root 2. 2 by root 2, 2 by root 2 is answer is root 2. This is what? This root 2 is called maximum value, local maximum value. 3 pi by 4 domain is over. Carefully observe. 3 pi by 4, the domain is over. So what we do? I solve here only, I write here only. 7 pi by 4. We substitute one more domain. We substitute one more domain. X is equal to 7 pi by 4. F double dash of 7 pi by 4 minus sine 7 pi by 4 plus cos 7 pi by 4. Okay, minus sine. This I can write as what? 2 pi minus pi by 4 cos 2 pi minus pi by 4. Correct? 8 pi minus pi, 7 pi by 4. 360 minus theta. Sine pi by 4. Why write I sine pi by 4? In fourth quadrant sine is negative. Minus of minus what? Plus. Cos is positive. Cos pi by 4. It is 1 by root 2 plus 1 by root 2. Root 2 greater than 0. Positive. So at x is equal to 7 pi by 4. F of x is minimum. F of x is what? Minimum. X is equal to 7 pi by 4 is called point of local minimum. Point of what? Local minimum. Local minimum value f of 7 pi by 4 sine 7 pi by 4 minus cos 7 pi by 4. This are written directly because I solved here. So minus 1 by root 2 minus 1 by root 2 minus root 2. Correct? Minus this value is also very important. If you write wrong, So they may cut 1 marks. Okay, minimum value, maximum value are very important. Minus 1 by root 2, minus 1 by root 2. So answer is minus root 2. This is very important problem. See the problem carefully. Next problem. Fifth problem, f of x. F of x is equal to x cube minus 6x square plus 9x plus 15. F of x is equal to what? X cube minus 6x square plus 9x plus 15. Okay, f dash of x. F double dash of x minus 2. F dash of x is equal to 0. I take 3 common. X square minus 4x plus 3 is equal to 0. X square minus 4x plus 3 is equal to 0. What do we do? X square minus 3x minus x plus 3 is equal to 0. In these two terms, I take x common. X minus 3 minus 1 I take common. X minus 3 is equal to 0. X minus 3 is equal to 0 or x minus 1 is equal to 0. X is equal to 3. X is equal to 1. These two are what? The critical points. Correct now? These two are what? The critical point. X is equal to 3. X is equal to 1. Sorry, this is what? Double dash of x. F double dash of 3. 6 into 3 minus 12. 18 minus 12. This is what? 6 greater than 0. Positive. Is maxima or minima? Minima. At x is equal to 3. F of x is minimum. F of x is minimum. X is equal to 3 is called point of local minima. Point of local minima. F of 3. 3 cube minus 6 into 3 square plus 9 into 3 plus 15. 3 cube is what? 27 minus 9 into 6 54 plus 27 plus 15. So you calculate all the values. So this is very important. So 6 cube plus 27 plus 15 minus 54. I think it is 15. It is 15. This is very important. It is what? 15. What? Minimum value. Local minimum value. So next, F double dash of 1. 6 into 1 minus 12 minus 6 less than 0. Negative. At x is equal to 1, f of x is maximum. Maximum. X is equal to 1 is called point of local maxima. Maximum local maximum value. F of 1 cube minus 6 into 1 square plus 9 into 1 plus 15. Calculate 1 minus 6 plus 9 plus 15. How much? 16, 15 plus 9, 15 plus 9 or else okay, 15 plus 9, 24, 24 means it is 19. It is 19. This value we call it as what? Maximum value, and 15 we call it as what? Minimum value. So next problem. See this problem. I think sixth problem. G of x by 2 plus 2 by x. So a restriction has given x is greater than 0. So we take the domain only x greater than 0. Okay, we check out. So differentiate it. G dash of x 1 by 2 minus 2 by x square. Correct na? G dash of x, we written like this, 1 by 2 minus 2 into x to the power minus 2. G double dash of x, G double dash of 1 by 2 is 0 minus 2 into x to the power minus 3. Derivative constant is 0. Minus into minus plus 4 by x cube. Because I shifted to what? Denominator. It becomes what? 4 by x cube. Okay. G dash of x is equal to 0. 1 by 2 minus 2 by x square is equal to 0. So that implies 1 by 2 is equal to 2 divided by x square. Cross multiply, x square is equal to 4. X is equal to what? Plus or minus 2. Since x greater than 0, that implies we take only the one domain, x is equal to 2. Because he has given the condition. What? X greater than 0. That's why I take x is equal to 2. So we check out G double dash of 2. 4 divided by 2 cube. So it is greater than 0. Positive. Correct now? 4 by x cube. 4 divided by 2 cube. Greater than 0. Means at x is equal to 2. G of x is maxima or minima? Minima. X is equal to 2 is called point of local minima. Local minimum value. So G of 2 divided by 2 plus 2 divided by 2, it is 2, correct? 2 divided by 2 divided by 2, it is equal to what? 2. Understand? See this problem, this is very important. Next problem. I think seventh problem. G of x 1 divided by x square plus 2. G of x is equal to what? 1 divided by x square plus 2. Okay. Differentiate G dash of x minus 1 divided by x square plus 2 whole square. Derivative of x square is what? 2x. That means minus 2x divided by x square plus 2 whole square. Again we have to differentiate G double dash of x by using quotient rule. X square plus 2 whole square means whole to the power 4. X square plus 2 whole square minus 2, minus into minus plus 2x, 2 into, this is very important, x square plus 2 into derivative of x square is 2x. Firstly we differentiate power, 2 into x square plus 2, derivative of x square is 2x. Better we have to simplify this one. X square plus 2 whole to the power 4 minus 2 into x square plus 2 whole square, okay, no problem, 2x 4x plus 2 into 2, correct, 8 x square, x into x square into x square plus 2, this is enough I think, g double dash of x, this is enough, okay, this is enough. Then to find the critical point we equate to 0, g dash of x is equal to 0, then minus 2x divided by x square plus 2 whole square is equal to 0, so lucky number 0, so minus 2x is equal to 0, x is equal to 0, only we got the critical point. Then we substitute here g double dash of 0. See, observe here, minus 2 into 0 plus 2 whole square, correct, plus 0, because 0 thing is 0, divided by 0 plus 2 whole to the power 4. So, minus 2 into 4, minus 8 divided by 2 to the power 4, less than 0, negative. At x is equal to 0, g of x is maximum. X is equal to 0 is called point of local maxima. Local maximum value g of 0, 1 by 2, because 1 divided by 0 plus 2, answer is 1 by 2. Local maximum value g of 0 is what? 1 by 2. See the problem, see this problem, very important problem, observe carefully, this is very important. So, okay, so up to this we stop, we continue the remaining problems in the next class. Thank you.